Drawing graphs is easy. You can get computers to do it for you. The more important thing is to know what graphs can reveal that numerical summaries can't, and the proper graph to use. Have a look at this dataset. Staring at it doesn't help very much, so let's calculate the median. If you have trust issues, pause here and check for yourself. Do you think the median is a good summary of the data? We have no idea. It's really hard to tell. Let's plot the data on a number line. You can see there are a lot of positive values and a lot of negative values, whereas it's quite unlikely you could tell from just looking at a bunch of numbers. Here's the median. We summarized the data with one number, and that number is supposed to best represent the dataset, but you can see it's nowhere near any of the values. There are things you can see on a graph that you can't see from a one-number summary. The takeaway message is, always plot your data, even if it's only for you to see. So you say, okay, fine, let's turn it into a graph. What graphs do you know? You know box plots. So you get this. Job done, right? Not quite. You don't see that the values are clustered into two groups. It's good to have a graph, but you can't just use any graph. This one doesn't work. If you use a histogram, you can see the distribution much better. Not only do you need to plot graphs, you should try a few to make sure you see everything you need. The second takeaway message is, the type of graph matters. Remember, data is just a bunch of numbers. The goal of statistics is to make your data informative. Graphs are a very good way to know what's going on. If you have one variable and it's categorical, use a bar chart. A bar chart shows the count as bars for each category. If you show the percentage rather than the number, that's a relative frequency bar chart. You can reorder the bars to make the graph more readable. You can do this because the bars are categories, so there's no inherent order. The bar chart is a visual version of the frequency table. See our Statistics in Excel course on how to create a bar chart, relative frequency table, and relative frequency bar chart using Excel. If you have one variable and it's quantitative, use a box plot or histogram. How do you read a box plot? The bar inside the box is the median. The edges of the box are the first and third quartiles. The whiskers cover a length of 1.5 times the interquartile range from the edges of the box. Values beyond that are potential outliers and are marked with a circle. See our Statistics in Excel course on how to create a box plot using Excel. A histogram, or frequency distribution, is the same as a bar chart, except with no gaps. This reminds you that you're dealing with continuous numbers, not categories. If you show how often the values occur as a percentage, that's a relative frequency histogram. Each bar covers a range of numbers, and you can play around with the number of bars. If there are too few bars, you may miss the details. If there are too many bars, you may be overwhelmed by the noise. Something interesting is if you mark the mean on the histogram, it corresponds to the point that balances the distribution. The mean is like the center of gravity. You can do this to roughly check that your mean is not ridiculous. See our Statistics in Excel course on how to create a histogram and relative frequency distribution using Excel. Other graphs you may come across are pie chart, segmented bar chart, stem and leaf plot, area chart, or radar chart. You may think, my God, I spent hours and hours in high school drawing these graphs and you don't even cover these. Why not? Many graphs are not the best to use. Even with this trusty pie chart, It's very hard to compare the relative size of the portions, whereas if you use a bar chart, you can clearly see the difference. The stem and leaf plot shows the individual values, but why would you want to replicate the data? What if you have a million values? That's not to say learning how to draw these graphs is useless. Pie charts teach you about proportions and how to use a protractor. But they're not necessarily the best way to summarize data. For more lessons on statistics, visit alphas&betas.org.